Hey, good afternoon, everybody. Thank you for hopping on here today and taking your lunch hour or your break or whatever to participate with us. I'm Maureen Gribble with UE Systems, and today we are joined by Bob Kazar. Bob has been in this industry for quite some time, and I've had the pleasure of knowing him for a good number of those years in our various. We were actually just reminiscing about the good old days with SMRP. So Bob's a wealth of knowledge, and he's got some great information to share with you all today. So the topic is maximizing reliability in a 24/7 manufacturing operation through condition monitoring and lubrication. He's got a really good story to tell. He actually presented this at our Leading Reliability Conference just a couple of months ago in Clearwater Beach, and it was so well received. We thought we'd kind of give a broader audience, those that weren't able to be in attendance, the opportunity to hear his story and his what he has to share. So we're excited about that, and you'll see his slides, are from the conference, so you kind of get a little vibe of what things were like down there in Clearwater Beach. Before I turn it over to Bob, just a couple housekeeping things that we like to go over. So we are recording this, so if you have to hop off or if you've got colleagues that would benefit from hearing this, we will pop this up on our YouTube channel. Just go to YouTube and search UE Systems. We actually have quite an offering of long form, short form, tutorial type, step-by-step type videos, all kinds of content over there. So I highly recommend, even if you're not popping over there to check this recording out, to kind of use that as a really good resource when you're trying to figure out anything related to ultrasound, of course. So just making a little point about that. We also welcome questions and participation. We've got some poll questions and some ways we try to be interactive. Of course, we're all sitting behind our computers at our various offices and whatnot, but no reason we can't try to be a little collaborative in this environment. So there is a questions box. You can for sure, type questions into that. I'll be keeping an eye on those. If it makes sense, I'll pop those over to Bob throughout his presentation if someone's looking for clarity on something, and then of course we'll have some time at the end as well. And if we don't get to all the questions, or if something's a little bit more specific to kind of a very unique situation, it might make more sense to follow up offline. We'll for sure do all of that. So don't worry if we don't get to your specific ask. We will be sure to do so. And then just always like to remind everybody, we are doing this live. We like that ability to kind of feel like we're all connected here for the next hour or so. But with that comes the potential risk of internet going out, audio issues. So just bear with us if we run into any of that. We'll try to address it and get us back up and running as quickly as we can. So with that, though, I am going to turn the screen over to you, Bob, and we'll let Bob take it away.
Thank you, Maureen. Let me bring this up. Go into presentation mode.
Yep, perfect. Looks good.
Good, you can see it all? Great.
Yep.
Okay, so hello, everyone, and good afternoon, good morning. I'm Bob Kazar, and as Maureen has stated, this presentation was done before at Leading Reliability Conference just a few short months ago. This is kind of a long title here, but basically what we're going to be talking about is an operations where we're making plant-based milk. It's at the time we were doing all this work, it was fully 24/7, and we were doing the best we can to take care of one of the bigger issues on the site, impacting mean time between failure on probably the most critical asset, or if not the most critical, tied for number 2 is the filler. And then, of course, this is what you're seeing here is the same backstop to everything that was presented at the conference. So just a little bit about me. I'll let you read this if you wish, but my background is electrician by trade through General Mills, up through the ranks, son of a plumber. So I kind of did both things. I do have 2 contractor licenses throughout my career, a little bit of work on the side, building my own homes, working on them. But my passion has been in maintenance and reliability. And my degrees are not in engineering. My major's in information systems. So I always gravitated towards, the computerized maintenance management systems, SAP PM for Owens Corning, Oracle for the wonderful company. Um, just in that space, a lot of data, but also a bit of predictive work, a lot of processing time, food, plants, and most recently, Califia Farms. It's a company based out of California. They make plant-based milk. So they're making almond milk and oat milk of many, many varieties and different flavors, but the base to them is almond and oat. And they had some issues in the plant around the fillers that I'm going to share with you that are fairly unique. And I would say I've been there just a little bit over 2 years. I just recently left. I now have left California. I'm now residing in Pennsylvania. So in this slide here on the left is the actual picture of the filler and the model from the OEM. The actual version that's in the plant is a slightly different layout, but very, very similar. It's a bottle filler. And the picture on the right is the very in-feed where we go ahead and we actually clean the bottles out as they initially come in. The bottles are blown already, of course, and they need to be sterilized. This particular unit in the center is referred to as the sanitizing carousel, and the wheels underneath it and around it, the one on the left is the in-feed star wheel, the one on the right is the out-feed star wheel, and the one in the center, of course, is the sanitizer carousel. So what the issue was is pertaining to these star wheels, the two bearings that support those star wheels have a very big impact on the equipment. Once they start getting loose, the higher the speed, the bigger the issue they can cause with jams, especially if the bottles get very small. These are all change parts. They get changed out depending on bottle size. And then, of course, once they become very loose, you can't even run it. It's just a jam every 2-3 minutes. So taking it down to work on it takes quite a bit of time. So we're gonna talk through this again. These are sanitary equipment, right? So it's almond and oat milk was the plant. Just to give you a little background of the plant's growth, it was double digit for basically over 10 years now that it's been in production. Just seems like plant-based products are really growing and taking off here in the States and elsewhere in the world. There's other facilities that Califia has throughout the world. And the growth has been very large everywhere. The plant itself, really has a lot of emphasis on reliability. But of course, there's also a lot of emphasis on meeting production demands and not shorting any customer orders. So it's a fine balancing act. So we had to try something different here as we approach these star wheels that were failing. And Maureen, real quick, just to check, am I coming through okay? Because there's a bit of noise in my background, but I don't know if it's coming through.
Yeah, no, it sounds pretty clear on my end, and
good. Right. It's very back there. I just want to make sure. All right, thank you. So this is the machine. Again, a little bit different view of it, different model, a little larger. So the way these machines work is they take a bottle in, they spray it with a sanitizer. The bottle is in the upright position. They're flushing it with a sanitizer to clean it. In the next station, they'll take the bottle and they'll actually flip it upside down. And as they flip it upside down, they're really taking the benefit of gravity because gravity works. And they want the sanitizer to rinse out. There's nothing in the sanitizer that can't hurt you, but it will clean out any microorganisms that could pose a problem. And then the bottle gets rinsed with something like reverse osmosis water. They refer to it as nano water, and sterile water actually, and then it's filled. And there's a little video on the bottom here I'm going to try to play, and this is the part where, as Maureen said, we're live, so can see an interesting ad as we bring this up. So let me do my best so you can see. This is about a little over a minute long, and you can actually see a glass bottle line, but at least you'll get an idea of what a filler is doing. So this is a glass bottle line, and this is the in-feed opener to let the bottles into a feed screw, or auger, some people might refer to it as. Comes into the machine and goes into a star wheel that's timed with, often referred to as the pincer. So the pincer picks it up and inverts it. So if there was any liquid inside, whether we're rinsing or if we were sterilizing, it's basically dumping it out and allowing sufficient time for the majority of the liquid to come out. In the case of Calafia, we would wash and then rinse and then fill. And then it's moved into the filling units, which again, we're relying on gravity here. As the bottle goes onto a pedestal, it's lifted up and it triggers the valves by lifting up on the valve stem, and it opens up the product to come into the bottle. And there's some ports in here to allow air out. And again, in this case, a very large star wheel is receiving the bottle so that it could be brought out for sleeving. And then, of course, for capping. This stage here, just putting the cap on. Right, and then it's rotating. You notice it's rotating in clockwise position, tightening the cap. So that is the bottling, and that is some of the star was a little bit larger though than what I had at Calafia, but not by much. The speed of that was about, I would say about 75 to 95 a minute. I didn't really check it there, but at those speeds, they seem relatively slow. However, you know, I've seen bottling speeds. A neighboring plant next to Calafia was well over 300, and Calafia is easily in the mid 200s. So much, much faster, in the area of 3 to 4 times. So I'll just put a little quick problem statement here, and then we'll get into it. All right, so we lubricated these machines every day. By the OEM, we had to lubricate as much as we could. On some of the smaller bearings, grease caddy in some cases worked. In other cases, the UE product, the grease caddy did not. We had, and I'll show you in a minute here, what we call a purge pot, a device that we can actually see the grease come out the other end. It's something the OEM built. But as this plant got busier and busier, they did not want to give us the machines. We were getting less and less time to work on them. And the problem was, if we did start to lose one of the many star wheels that were in the machine, two machines there, one had 9 and one had 12, you could take quite a bit of time to like over 4 hours sometimes to actually repair it. But we thought about using some vibration, and actually the plant near us, a farming facility that had a filler for carrot juice actually, and some other juices, actually tried vibration and failed. And I'll explain why and show you some of the data as to why the vibration did not work for us, at least not in the sense that something easy to use that was pretty much right on the mark that we required. So the mean time between failure was about 90 days on average. It varied a little bit on the location of the filler. Some cases, maybe we got as much as 120 days out of it. But the bottom line, because of the environment wet, the speed, and then also because of the sanitizer solution we use, very corrosive to even 316 stainless. And then the one thing we did observe, though, was that as we started getting looseness in the bearings on these star wheels, and we could actually see an increase in the jams. That was one of the ways we were starting to realize that we needed to take a closer look at a star wheel. So again, there's the picture of the sanitizer. It's in-feed star wheel on the left under the hose, then the carousel that actually has the nozzle spraying down into the bottles, and then the outfeed star wheel. And then the upright position, you see, the star wheel assembly in its upright position, there's the actual filler deck, and that's where we would grease at, and we would come in below the lower bearing, a thrust bearing, and we'd have to grease through and up the chamber and out the top bearing into what they call the purge cup. Problem with the purge cup, though, was that it was inside the machine. In order to see in there while it's running, you pretty much need to open the guard door, meaning you need to stop the machine. This is where we started running into some issues with, trying to lubricate the machine and keep it running as much as possible. So we had to try a couple things, like moving the purge outside, potentially, working with the OEM on a different approach to trying to pump the grease from the bottom up through two bearings and out into that tank. Just a couple things. And then, of course, one of the first things I did, focusing on reliability, is make sure I had the best bearings I could put in there. So that assembly, when it came apart, took quite a bit of time. And I think this next slide will show you some of the feedback. Well, here's the dashboard for the on-track system. So let me clarify a couple things here for you. So this is looking at the dashboard is our filler number one, and it's just a layout that UE system gave us after we had a couple weeks of data, get the data normalized, and look at where we should apply, the indicator for what good is, what the green is, the blue indicating the likely lubrication point, the yellow is you got a problem, and the red is you definitely got a problem. As it gets into the yellow, though, we've had times where we've lubricated and not had an issue where we had to do any type of repair. The variation, though, comes from the location of the bearing, or excuse me, the sensor to the bearing, but also where the speed of that particular part within the machine. And depending upon where it is in the machine and what product is being run and what bottle size is being run, speeds vary. And this introduced a problem for the vibration analysis and led us away from it, just like it did at the local company that had tried it previous. And how I knew they tried it previously, using vibration, is because I shared the cost for the vibration company that flew out to California, and we would split their travel costs as they went in. The company went in and did the vibration analysis for the juice plant down the road from us, and then they would come over and do our vibration on our facilities, mostly utility equipment. And we got it to talking. We realized they had the same exact fillers and were presented with the same problem. So this is the dashboard, if none of you had seen that, right? And these settings in here can be adjusted, what's green, blue, yellow, and red, and where they would appear. And the graduates there are in decibels. Here, and hopefully you can see this well, is the actual blaster that I showed you in the picture. The upper is the in-feed star wheel, the one on the left that was underneath the blue hose, and the one below that is the actual carousel in the center. And you can see here that, looking at the red, and the red being the actual real-time data samples taken, there's a lot of on-off going on, which poses a pretty big problem for us trying to understand how we could apply a condition-based or predictive technology. You notice about a little past halfway through the graph, there's a pretty big down period here where it's off. This is where the line was in a mode called CIP, clean in place. For most dairy facilities, and that's what this is, it's a plant-based milk, but like regular cow milk, you could purchase milk in the store. We have to go down about every 60 hours or so to do what's called a clean in place. That's where everything gets shut down, rinsed out, and then caustic and acidic cleaners are applied in different sequences over a period of time to clean it out. And that's a period of time that we can get some maintenance done on the machine, but not for the entire time, because you're actually cleaning the filler too. The little blip you might see about a quarter of the way into there is probably when they had to run the machine to cycle through the valves. So what you can see here, and the blue is the average, the blue line on the graph. The red is the real time, taken every minute. And there is the capability to unlock it. It's a little hard to see, but underneath the A in caps, there's a little lock. If I unlock that, I can actually change the timeline here and even get real-time data. Um, but the other thing I can do too is I can get this data out into a common delimited file. So just a little bit more on the scenario. So mean time between failure, I said, was about 90 days um, on average across all the star wheels in those two fillers. It's about 4 to 5 hours, depending on which one it is, to completely repair. Only a few $100s in parts. And then the biggest thing was the production loss. You know, my counterpart, she was a sweetheart. But boy, when we had to go down for a maintenance related issue, this is probably one of the sweetest things I've heard. And then other than that, I got issues observed leading up to the failure, you know, is that on the slow speeds, you know, like 120 minutes or below, um, you know, it was very hard to detect, of course, but the number was lower on the jams until the bearing went catastrophic. And you could really feel looseness in it, and you get a jam maybe once every 5 minutes versus once an hour. That could have been a dented bottle or something, you know, a different variable that's in the equation. But above 120 bottles per minute, which was normally the case, um, once you had jams about every 5-10 minutes and it wasn't the bottle issue, you knew something was up. But by then it was too late. You couldn't continue to run until the next CIP cycle. The smaller bottles, these are the three sizes that they were running at the machine at the time. There's another now. The smaller bottles were really prone to jams because they ran at the highest speed and also required the most precision. And as I mentioned earlier, on a similar filler, a local non-competitor, one that we had shared the vibration company with that was out checking our utility equipment, they had tried and tried, and it just they failed in their capabilities to detect anything on the star wheels. The gearboxes, motor underneath, that's another story, but definitely not the star wheels. So if you're not familiar with the on-track system and the sensors, they are mounted, and the direction you will get from you is to mount it right as close to on top of the sensor as you can. We mounted quite a few in the 30 range. In that range, we mount them top and bottom on the star wheels using the supplied epoxy. In the picture on the right, you could see the small little plastic tab that it's like a peel off there, and then you apply the two-part epoxy and you mount it, and then in the bag next to it is like an audio dampening cushion that goes over top of the sensor. I bring this up because the install took a while for us. We got everything down on a down weekend. We got a down day. We cleaned everything up, took advantage of the downtime, and installed everything. So then we come up with this little question that popped up, like, okay, I wonder how it's going to hold up with the parasitic acid. Parasitic acid is what's used to sanitize everything inside the machine, and the acid is stronger. Just about every single one did come off, and we did everything we possibly could. But the fix was simple. We went ahead and attached all of the sensors to their studs. That's inside that little plastic unit you still see up at the top there. But we did it with a clamp, with a stainless steel clamp. Works just as well. The epoxy was faster. We had to customize a couple clamps to account for different fittings going in and out of the tube that supports the star wheel and the bearings. But for the most part, this meant that everything had to come back out and wait for another down weekend again. But this parasitic acid is part of the problem. So on the picture on the right, give you an idea of what the deck looks like underneath where the bottles are transferred. You could see purge bottle all the way to the right. You could see the column that supports the star wheel. and you can see the sensor. You get a good look at the sensor, you can see the clamp. That was one of the first clamps we made. That was one of our test clamps. You could see we took the clamp and we actually had to cut it to account for um, the fitting coming out there. That's the grease going over to the purge cup. That means that that sensor is mounted above the bearing. It's probably just at the upper side of the bearing. And this mounting position is what varies throughout the machine. And that's why on the dashboard, we had so many different normal or average decibel settings. All right. So the installation, we had to get past the parasitic acid. We installed 17 sensors on 2 fillers. The decision was made that the lower bearing is, when they take it out, they've seen some wear, but it's never failed. It's always the upper. So we only put the sensor on the upper. We went with the stainless clamps. We did the best we could to get to the center of the bearing to get the most sound we could get. That variation, though, is why you see differences on the dashboard. And it's just something that we had to take some time to make sure that we knew what was normal. Or like when we're looking at this picture here, we had to decide, okay, what was normal for this bearing. Here's a couple examples after the install was completed. You could tell in the case on the picture on the left, we were right on top of that upper bearing, which gave us the highest dB readings and that we could hear on and basically visualize on the dashboard. And then on the right, just a little bit closer look at one, again with a clamp, really no interference. And then of course we have the noise dampening cushion around it with some tie wraps. So the analysis here, to get down and get into the lubrication part, what we had to do is, since we're up and down so much, and the reason why we're up and down so much is because the sleeves will run out about every 12 minutes. So then we got to shut down. There's not a lot of backup between the sleever and filler. So the filler has to stop, or there's a jam, or something downstream from there, or it's a product change. Many product changes on one of the lines versus the other one seem to run a little bit longer periods. But just a lot of up and down, which is really is considered normal. But as we over time have reduced issues with the sleever and other downstream equipment, it's improved quite a bit. But you can see what we're dealing with here and how hard it would be to apply vibration to this, especially when it's up to the operator to select the speed, and depending on the size of the bottle, viscosity of the material, the product controls flow, so it might have to change speed. So it's just, knowing the speed and tying that information back, we took a stab at this with David Shaw from UE Systems, George Seminoff from a local reliability company I've worked with in the past. George and I go way back, and then of course Kelly Krent from UE came out and helped us get this up and started. She was out for a whole week with us, and we got this going. So when you look at this data like this, you can download all of it. Everything that's in your view is downloadable. That's in your view. And then here, these two particular sensors are probably located very close to their bearings, given the higher readings here. I use this because I think this was a good example. I did have some that were below 10. All right, so what you have to do with the OnTrack in order to get this downloaded is, once you have your time frame, you can get this drop down. You notice the bottom right, the drop down, export to CSV, right? So I always refer to as comma delimited. And then from there, you can put it into Excel. So what we did with this particular data is we downloaded it, and every single data point gets put in Excel with a time date stamp. And we worked on this data. And from this data, I was able to take timeframes that were running its average speed and level for that particular product, and compare like before the CIP with after the CIP. So what you need to know about this data here is that during the CIP, we lubricated. All right? We lubricated this particular machine. And we know what the average was before we went into the CIP of this particular star wheel. And we know what the average was after. Both sets of data were in the same download. And if you look at it and you see that trough where the CIP was, you could see how the blue, the average on the left, just by eye in it, you can even see that it's higher than on the right. So that's the impact of the lubrication. And what we found is once we get running again, that over a period of time, hours, that we start to creep back up. So the green line represents, should be about your average high. The blue line, hey, this is when you should be lubricating. And in actuality, we can start bringing that blue line down a little bit because we know about when that's going to happen. And the system will actually send you an email. At the time that we did all this, of course, we stifled the emails because we knew we were going to get way more, and I didn't want to build a system out that everybody didn't trust until we got it, worked out. But you will get emails depending upon what level you're at, right? So re-lubrication or, there's a concern. All right, so again, I downloaded the data here, all those data points every minute. The decibel level I was able to see with their time date stamp, basically corned off a certain amount of time, figured out the average, did the same for afterwards, and I got about 1/3 dB drop in almost every single case. I think it was only one exception where we didn't drop a third of the dBs. So if 15.4 is the average, and it is here for the last, I think it's 10 minutes, and somebody can correct me from you if I'm wrong. The last few minutes is what's being displayed here. But after the lubrication, it always dropped about, in this case, it would drop about 5 decibels. It was just as plain as could be. All right. And we can bring this back up if there's some questions at the end. So again, this is how you download. And then through some analysis, you can determine, okay, what lubricated sounds like and what, is a normal running sound. So what we determined here, right, this is for 2 different lines, of course, that, average dBs before the lubrication was like 15.36 over the last 2 hours of the run. And then it dropped down to 10.44 on this particular. And I had to do this with basically everyone to really understand what that change was. And over time, I believe that you can start just dialing these in. What you have to worry about is those anomalies where something pops up higher. You just don't want to, cry wolf, false alarm, and have the system seem, untrustworthy by having, a lot of emails going out for something that's only due to maybe a jam, right? That little, I don't know if you can see my cursor here, but right here, if that could have been a jam for all I know, that brought us above, you need to lubricate level. So we determined since filler 1 runs slower than filler 2, that we could actually go 48 hours before we had to lubricate. Filler 2 runs a different speed. On average, it's 42 hours. And it's the strategy with the CIP being at 60 hours doesn't always allow us to wait for CIP. So we got to basically catch product changeovers or other opportunities if we want to get in there while it's down. Most of the lubrication can be done while it's running, and some projects in play here to be able to do all of it while it's running. But there are still some things underneath that require the equipment to be down that will probably always be on a CIP cycle. Next steps now would be to take the remaining on-track sensors. So like I said, I think one machine used 9, one used 12. The system was purchased at the max number of sensors, which is 16 for each on-track system. So that now is going to allow us the ability to go underneath the machine and start listening to the main drive, motor, and the other gearboxes, which there's plenty of, and monitor their health as well. Now, we've been creating work orders for the lubrication and training the lube techs to look at the data. Since I left, I don't know what kind of where they are with that. Hopefully, they're at a point now they can actually do that themselves and not require somebody with reliability background or someone other than just the technicians themselves can see the noise and also look at the dashboard. And then, of course, we'll turn on the email notifications once we're comfortable with where we set the high limits. So the team involved with this was myself, of course. I was the maintenance leader at Calafia Farms. UE Systems was David Shaw and Kelly, which I mentioned earlier, and then local reliability engineer from Growers Technology is George Seminoff. The plant still uses some vibration. I'll share a few things about the plant, then I'll open it up to some questions, but just so you know, a couple other things about the site. We're using triaxial vibration sensors, transducers, accelerometers rather, and we have 39 facility items. The blending area is where we can use the UE grease caddy and use it quite a bit. The global conveying system as well. We had a UE 10,000 there. We're building some routes for the overhead conveyors to be inspected. We do some oil analysis. And then we're looking at an empath system for one of the submerged wells to monitor the health of the submerged motor and pump. It was down about 768 feet. That was the water, which is, by the way, the most critical asset to the plant was the water well. And then the lubrication program, we started with 39 lubes. When I got there, there was, I don't know, maybe 10 different brand names out there. Some of the gents that have been the craftsmen and senior operators, they all had their own greases. Nobody knew why they had a certain type, but everybody was trained at a basic level, tribology. We color coded everything. We got down to 14 lubricants. And Calafia and Bakersfield is a lubriplate house, all lubriplate products. An overview of the organization, just to give you some background on it. We do technical training monthly. So I'm always looking for something that's technical nature for the maintenance guys. There's some soft skill stuff that goes on too, but a lot of hands-on technical, some in-house, some outside. We have a skills matrix that was created for all new hires and to qualify them for production support roles as well. I think I got 4. On my left, there were 4 that came out of the operations department that are now craftsmen in the maintenance department. Do some soft skills training on how to train or coach operators, and then also how to deal with difficult people, because sometimes craftsmen are difficult people. And when they're dealing with a difficult person, they normally don't train very well. So we had lined out some training on how to be a good coach. And then the one thing here I'd share, and I don't know why there's 2 number 4s next to it, because it's so important. I've been around for a while, and I know how hard it is now to get good technicians and keep them in facilities. As the maintenance leader at Calafia, before that, as a director in Wonderful and at Owens Corning, I hired maintenance leaders. I used to mentor maintenance leaders, help them hire good technicians. But I have to say, hands down, all the schedules I see, this is probably the best when it comes to keeping craftspeople happy. These 3 days on, 4 days off, 4 on, 3 off, 12-hour days. Guarantees them some overtime. And I only had one person in that whole time I was there leave. Sorry he had to leave his hours, but he wanted some specific medical care with a local ice cream company. Other than that, everybody loves this schedule. Just a fantastic schedule in everybody's eyes. And even the individual that left was, it told me on his exit interview, he was very sad to leave the schedule. Last thing I'll say before we open it up for some questions is, in my career, I have to admit SMRP was a great help. And I was chairman of SMRP in 2016. The body of knowledge, the people you meet, and then if you're interested in metrics, they got 68 maintenance reliability metrics that are just excellent, that are open to the public for purchase. But if you're a member and you don't have them, you should get them. Get online and get those metrics. You can download them. There's no charge to the membership. Great to use in whatever situation, whatever endeavor you have related to M&R. A Global Forum for Maintenance and Asset Management. It's a large international group. There's 13 associations in it now. I think Morocco just joined. GFMEM has a lot of focus, not all, but a lot of focus on the ISO 55001 standard, building support documents for it. They did create a maintenance framework document. I think anybody who's a maintenance supervisor or maintenance manager, or even a director, if you don't have the maintenance framework document, I strongly recommend you go to GFMAM and get it. There's also a document called Landscape. Actually, I'm leading work stream 5 on that. There's 7 work streams actually rewriting the landscape. We're in version 3 right now, in preparation for changes that are coming out of ISO 55001. If you're not familiar with 55001, I put a small blurb below here of what it actually is. And then also I'm a member of IFMAA. The focus has been basic on facilities, but I've always leveraged them because they've had a lot of good information on, like when I had to take care of roofs. That's not really something you find a lot of information on in SMRP. You will, but not like you will in IFMA. And they also have a ANSI accredited certification like SMRP. They have a CFM, SMRP has the CMRP, both ANSI accredited. So these are the 3 that I'd say that if you're looking for more information in your career, these are good places to go. And a lot of it is free. I don't know about the IFMA because I'm a member, so I have access. I never try to access them without being a member. But a lot of good information. Very big association as well. It's just as big as SMRP. And I think that's all I had. I'll turn it back to Maureen and any questions, and if there's any slide we need to take a look at, we can do that.
Yeah, awesome. So thank you, Bob. That was a great presentation. So while you guys think through some questions, just want to kind of ask you all a couple questions, just because we're always kind of curious and it's sort of helpful for us to kind of have an understanding. So definitely type those questions in. And Bob, we've already got a few, but if you all wouldn't mind answering, just always kind of curious, like who's using any type of automatic lubricators at your facilities. We'll just leave that up here for just a couple seconds here. Looks like about half and half. So that's interesting. All right. And then, of course, we're always curious who and how many of you are using any kind of ultrasound for condition monitoring, especially for specifically for bearings at your facilities. Wow, we've got quite a lot of you are, so that's that's fantastic, and probably what drew you to this case study webinar today. So that's super helpful. And then last but not least, and this, again, a little more self-serving, but we want to be in touch with those of you that are interested. But Bob obviously shared quite a bit about this on-track system that we've had out for almost 3 years now. But if you are interested in a personal demo of that, let us know so we can be sure to be in touch with you. And if you're not ready for that yet, we won't bug you about it. So there you go. So thanks for taking a little bit of time to answer those for us. All right, so Bob, and I'm going to just reiterate what Bob was saying about those resources, industry resources and organizations. Definitely great places to get a lot of information, and great opportunities at all of those organizations as well for, actual volunteer opportunities. As Bob mentioned, he was chairman of SMRP, and he actually before that, he had been on the conference committee and things like that. So there's a lot of really good opportunities if you're wanting to kind of get more involved in the industry, and have some kind of nice, accolades to add to your resume. It's really a great opportunity, and there's ways to get involved that don't require a ton of your time, and then there's some opportunities that do require a little bit more time. So it's kind of whatever kind of suits you, but I'd highly recommend looking into any of those groups. For those opportunities. I think you'll find it rewarding, and the folks you'll meet along the way as well. So anyhow, enough plugging that. So Bob, one of the questions that was asked, and maybe I don't know if you're going to be able to answer this, but when you were talking about your technicians and all of that, they were wondering like kind of what a standard hourly pay rate is for technicians. Is that something you can answer?
Yeah, so I would say on average it was in the low 30s for that particular area, and it varies in California. Keep in mind, California is one of the largest states. So in the Central Valley in California, it's much lower cost of living than if you get down, say, to LA or any of the coastal cities. So in the mid to lower 30s is a fair competitive average.
Okay, cool.
Hopefully that answers the question. Now, if I go to the coast, if I'm up by San Francisco, San Jose, or LA, of course that's going to go much higher, because of just the cost of living is very, very different between Bakersfield, Fresno, LA, and San Francisco.
Gotcha, for sure. Okay, and then a couple folks kind of asking sort of similar, but just sort of wondering what kind of pushback you got, if any, when you brought this on-track, system to the, that you wanted to implement this? Did you have to do a lot of convincing of people, or was it pretty much, this is what we need, and we're gonna just get going? Kind of how?
I'd say this is one of the easiest ones. The plant manager, Levi, he's a former Army drill sergeant and had a lot of respect and a lot of support for the maintenance organization. So I went in with basically a 6-digit predictive maintenance condition monitoring capital project. I had to basically show the return on investment. The fillers, of course, stubbed our toe until we brought in UE systems, and we put the system in there, the filler room, and then the vibration went to the utilities. Although in some cases, now that I have some time and experience with the UE on track, we could have probably done some vibration just as easily with the ultrasound on the utility equipment. There are some exceptions, though, but for the most part, we probably could have done about half, I'd say. But I didn't have this is one of the first times I had this really, I wouldn't say it was like carte blanche, by no means. I had to justify everything,
Right.
criticality of assets, the cost benefit analysis. However, he was very, very supportive. In the scheme of things, when I took over, I would say plant was in that 75 to 85% reactive range, and they were sold out, so not a good situation. I'd say they're probably more around the 30-40 now, where the hardest things are still, they're still working on some things more related to product, people starting up something wrong, or maintenance, maybe issue related on a rebuild or operator problem. But yeah, they're going to have some fun with this last 10 to 20% of their reactivity to try to get it down below 20. But very supportive. So I'm lucky in that sense for maybe the first time in my career.
I was gonna say, I think you're making a lot of people really jealous.
Yeah,
So
yeah, I was happy with it. I mean, Levi was right there. All I had to do, and I had some engineers give me some pushback. But you know, coming with a lot of history myself and dealing with it, um, they weren't too big of a problem, especially when you get the support of the plant leader. But he had seen it, right? He had seen it work. So if the leadership hasn't seen it, then the best thing you can do is show them a plant that had to go through a do I believe in this or not moment, and that means maybe a little bit of benchmarking or someone that they would respect. Come talk to them and talk about the technology that you're looking to apply.
Yeah, that's great advice, and I'm sure you've got stories for days of the times where things weren't so cut and dry and easy to move forward something you were hoping to implement. So hit Bob up on LinkedIn, and maybe he'll share some with you. All right, another question that came through, was the reliability engineer the one to analyze the data and determine the lubrication frequency? Then that schedule passed to the maintenance lubricators, or was everyone involved in the entire project?
It was the reliability engineer who was me. So it's a small facility in the sense there's not a lot of people. The engineer that supported the project was a capital engineer, so I didn't really expect much help from him. So in between my maintenance manager hat, I did this with support from Kelly. I had quite a few phone calls with Kelly from UE. I had my supervisors in there. I made one of them pretty much brought him up to the level of knowledge that I had with respect to the data history we were looking at. And then we were working on the lubricator. The two technicians, one in particular, that lubricated the fillers all the time. He was the one that had the most exposure. So really wasn't a reliability engineer. We had to do it internally with the people we had. Be nice if we could hire a reliability engineer. Maybe now that they get that I'm no longer there, they might do that. I don't know what they're going to do for a maintenance manager though, but um, that's up to them at this point. But I had to do that working in between the other duties, which was another reason why I think it took so long to really to get it all finalized. Being a former project management professional and carrying that PMP designation, what bothered me the most about the project was the fact that I couldn't execute any faster because there was just so many things to take care of as well as getting this project moving. But good support from the vendors. You want to make sure you got good contacts and reliable people. And I've known UE for many, many years. I actually did a keynote for them back in 2015 at their conference
That's right.
and put in many of their grease cans. Um, and a lot of the equipment, for me, just put a plug in for the grease can. I just love the fact that the learning curve is so extremely steep when it comes to ultrasonic. When you have ultrasound and you could get somebody trained up in hours and they can start bringing value. So I've always been a big proponent for use of ultrasound, but all types of technology.
We are not paying him to say that, you guys. That is coming from the heart. But we appreciate it. Thank you.
I can send an invoice.
That's right. Sure. We'll make sure it gets taken care of. All right. Well, awesome. So, if anybody thinks of, well, actually, hold on a second. Here's another question. What advice would you give someone attending a reliability conference for the first time next week? So, Chris, I take it you will be at Reliable Plant. So come say hello because I will be there as well, and it would be great to see you. But yeah, Bob, what advice do you have for folks attending a reliability conference, particularly?
Okay, so I've been to a few,
Yeah, I
to
was
say
gonna
the
say.
least. All right. So the best approach you can take is read the synopsis on every single presentation that's going to be there. And typically they're short, a paragraph or two. And then see if that's going to work for you and rate it. Use a scale, put a 1 to 5 on it. 5 being the best, one's like, I don't think it's really, I'm not going to get a lot out of it. And I'm not saying it's not that it's good material, just not good for you at this time or whatever stage of project you're in or your career for just learning. So read every one. And then after you're done reading them, you're going to have a few that contradict, like, oh, wow, they're both at the same time. They're different areas of the facility, different rooms, but they're at the exact same time. Which one? Then read up on the author, the presenters. I really like practitioners and industry partners like consultants or contractors that worked with a practitioner. I like those double presenters. To me, they're some of the best. You got the guy that's not the usual presenter that you're going to get the cold hard facts, right? Where the consultant, he's taken the time and he's made sure it's laid out where the data is going to present to you so that you could acquire and absorb it. So, and at SMRP, we've always rated the submissions um, for presentations a little higher when we had two presenters, one from the factory where the case study is and one from, say, UE Systems that, supported them in the project. So, and then the other thing I'll say, since I am a little cynical at times, is that you never know. Well, you don't know what you don't know. So you could be sitting there figuring, I picked the best one, and you're 3 minutes into it, and you realize this ain't gonna work. This is not gonna work. Have your plan B so you know where to go. And then if you go in a couple minutes late, well, so be it. But at least you got your money's worth at a time you're gonna spend it.
Yeah, those
You
are
think
great
anything else,
things.
Maureen?
Yeah,
I
I think
mean,
the other thing I was going to say, because you nailed it on the sort of picking out your agenda and what you want to be sure you catch, and having those kind of objectives laid out ahead of time. But I would also say, just, don't be shy. Find people to sit with at lunch, strike up conversations. I think a lot of the best learning and benefit you receive at these conferences is actually in those conversations, and then the relationships that you might likely build as you leave the conference, if you connect with them on LinkedIn and things like that. I think that kind of building up your network and your community of peers is a great thing to keep an eye on when you're at events. So definitely don't be shy. A lot of people are there kind of by themselves, so people are in the same boat. Um, and yeah, I think you'll hopefully have a great event. So like I said, come say hi if any of you are going to be at Reliable Plant next week. We have a booth there. We've got some presentations as well that we'll be doing. So come check that out. We'll appreciate getting to see you in person. And then I'm gonna just grab this screen back real quick, Bob. So as he mentioned, he was at our leading reliability conference. And my screen's getting crazy. And so just want to throw the dates up. Speaking of reliability conferences, our leading reliability conference will be next May 14 to 16 in Clearwater Beach, Florida. I think it's a great event, especially the content, like what Bob was saying. The majority of the presentations are folks like Bob. They're people who have actual stories to tell, the trials and tribulations, and then the eventual successes. So definitely keep that in mind. We'll have a lot more information coming out soon with the agenda and things like that. But if you could at least pencil it in on your calendar, I think you'll be pleased with the event if you do attend. And then I'll just leave our contact information up here. So again, we were recording this. We'll have it up on our YouTube channel later today. Anybody that has additional questions, you can definitely reach out to us, and we'll get you hooked up. If you want Bob's contact info, I can get that to you as well. And he is a great resource, and I know he is very willing to be of assistance to those that have questions and things like that. So Bob, thank you again. Really appreciate you taking the time. And to everybody that attended, thank you all so much. And with that, we'll let you all go and enjoy the rest of your day, and we'll catch you guys later.